Hi there, welcome to www.highschoolmaths.co.uk. Today we're going to be looking at how you simplify a ratio. So we're going to look at a few simple examples to start off with, and then a few more complicated ones involving fractions and decimals. So the basic idea of simplifying ratio, very similar to simplifying fraction, is you're looking to make the numbers as simple as possible. Very similar to your fractions, if we look at this first example here, 2 to 10, if you think of how we deal with the fraction 2 over 10, they're both in the 2 times table, so we divide both numbers by 2. And that's the exact same approach we're going to take here. We're going to divide the left-hand side by 2. I'm going to divide the right-hand side by 2. That still keeps the ratio balanced, but you've got a more simple ratio where we're going to go down to what's called a unitary ratio here. So 2 divided by 2 is 1, 10 divided by 2 is 5. And that means you've got a 1 for every 1 of the left-hand side, you've got 5 of the right-hand side, and that could be whatever categories you want. And that scales up to 2 to 10. And it could scale up even further, just like your equivalent fractions. So there's a lot of similarities here with your work on fractions. If we look at the second example, 20 to 24. So if we look at them, they're both in the 2 times table. You can definitely spot that. They're even numbers, but it makes much more sense here to go with the highest number. Okay, so we'll go through both approaches with this and see how it works. But I'm going to start off with the highest because that's what I would always encourage you to look for. So we divide by 4 because they're both in the 4 times table. That gives us a 5 to 6 ratio. Okay, now that's going to be our final answer there. But let's take that question again, 20 to 24, and let's say, okay, I didn't spot that it was in the 4 times table. I only spotted there were multiples of 2, so I divided them by 2, and up with 10 to 12. What you'll notice there is because it's 10 to 12, that can be simplified a step further. So can you simplify that again because they're both multiples of 2. So you can divide them both by 2 again, and you still get 5 to 6. Okay, obviously it's better to only have one step because then you're less likely to forget you're working and you're having to do less working. But sometimes you might not spot that, and sometimes you might want to do additional steps if the numbers are really big or really awkward, like in question C maybe. So for question C, probably the number you might think of first is 5 because they're both in the 5 times table. They actually can be divided by 15 because they're both multiples of 15. So again, we'll go for the highest one. Divide by 15, divide by 15. Okay, so how many 15s go to 15? 1. How many 15s go to 45? 3. So we get 1 to 3. But again, if we take that, we could, let's say we just thought, we'll divide by 5 because we know they're both the 5 times table. We'll get 3 to 9. You'll spot that both these numbers are now in the 3 times table, so we can divide that by 3. Okay, and then how many 3s in 3? 1. How many 3s in 9? 3. We end up with 1 to 3 still. So we end up with the same answer. There's just more steps to it. So it's entirely up to you. As long as you always check that your final answer is fully simplified, that's the important thing. And we'll look at this last one. So they're both multiples of 100. They both have 2 zeros at the end, so we can divide by 100. Divide by 100. That gives us how many 100s go into 100? 1. How many 100s go into 2,000? Well, that would be 20. So we get a 1 to 20 ratio. And that's a simplified ratio. So that's the kind of idea. If you're good at your times tables, you should find that quite straightforward. You're just identifying what's the kind of common multiple within all the numbers in the ratio. And you can extend that to having a three number ratio as well. So let's look at how that works with decimals or fractions. Okay, so ideally we don't want, like when we're dealing with fractions, we don't want a decimal within a fraction. We don't want ideally a fraction within a fraction, especially as a final answer. So we want to simplify it, so we're using whole numbers. Same idea with ratio. So what we're going to do first of all is scale the ratio up. Okay, so if we look at this first example here, 3 to 0.6, what I'm going to do there is multiply both by 10. Okay, and there's lots of different ways you can do this, but I find just multiplying by 10, 100, or 1,000, depending on the number of decimal places you've got, will be a good starting point. Okay, so let's say we multiply by 10. The reason we do that is if we do 0.6 times 10, that gives us 6. 3 times 10 is 30, so we end up with a ratio of 30 to 6. Now you can see from that two-step approach, 30 to 6, they're both in the 6 times table, so we can take that down another step, and then we can simplify. So just what we were doing in the previous page. So we scaled up first to make the numbers easier to deal with, and then we're going to scale back down. So we're going to divide by 6, divide by 6. How many 6 is going to 35? How many 6 is going to 1? How many 6 is going to 6? 1. So you've got a 5 to 1 ratio. Okay, let's look at the second one. So half to 2. So in this case, if you're dealing with fractions, I would recommend you always multiply by the denominator of the fraction. So in this case, we're going to multiply by 2. Multiply by 2. So 2 times a half is 1. 2 times 2 is 4. And actually, that gives us the final simplified ratio because we can't do anything more with that. We can't divide that any further to simplify. So 1 to 4. Let's look at the next one. My ratios are kind of clustered together a wee bit here, but we'll fit them in. Oops, there you go. So 3.6 to 2.2. So again, they're one decimal place. So we're going to multiply them by 10. If they're two decimal places, we can multiply them by 100 and move the decimal point 2 places. But that's one multiplying by 10 here is going to work just fine. So we get 36 to 22. Okay, so looking at them, I can see they're even numbers. Can't spot anything higher that we could divide by, so we're going to divide by 2. How many 2's in 36? Well, that would be 18. How many 2's in 22? Well, that would be 11. And that gives our final simplified answer. 11 is a prime number. We can't do anything more with that. And the final one here, which I've left myself barely any room for. So the final one here, I'll just try and squeeze in. We've got 3/4 to 4 as our ratio. So what we're going to do is, again, multiply by 4 because that's the denominator. So I'm going to multiply by 4. Let's squeeze that in here. Multiply by 4. That's what I'm doing. That's kind of going down here. So 4 times 3/4. So if we multiply by 4, when you multiply a fraction by a whole number, you're multiplying the top part of the fraction. So 4 times 3/4, you would get 12/4. So I'm going to just lay that out here. It could help with some of the more complicated examples. 4 4s are 16. Now, in your head, really, 12 divided by 4 is 3. So what we're actually doing is we've got a 3 to 16 ratio. Okay, basically for this first line here, when we multiply the fraction by 4, that cancels out with the divide by 4 on the bottom of the fraction, so we're just left with a 3. Okay, but there's different approaches, so being able to see that kind of working might be helpful, especially if you have a fraction on both sides of the ratio, and then you have to start thinking about what's the lowest common multiple, or lowest common denominator that you could multiply the whole thing through by. But that's something to develop onto after you're confident with all of these ones. Okay, that's a kind of quick summary of how you simplify simplify ratios. So hopefully you found that quite helpful. It's quite a simple process once you get the hang of it. Most ratios you'll come across will be fairly straightforward to work with in terms of the simplifying. So hopefully you'll find that useful. But if you need to go back and just go over any of it again, it's there for you. And if you want to check out any of the other maths videos, like the equivalent fractions or whatnot, or practice some worksheets, there's plenty of resources on the website www.highschoolmaths.co.uk. If you did like the video, please don't forget to click the like button and subscribe, and please share this video with your friends. Let them know how awesome this channel is, and thanks for watching, and have a mathemagical day.